Morning, Algebra 1. This lesson, it really ties back to what we did in Module 1 when we solved systems of two variable equations, graphing and algebraically. So we're going to use this to look more at our absolute value equations. So first of all, let's try to remind ourselves how to solve absolute value equations. Little review here. So solve for x in the following equation. First of all, the first thing we need to do, yep, that made sense, is get that absolute value part by itself by adding 3 to both sides. I get absolute value x plus 2 equals 0.5x plus 4. Now this really turns into true problems because the absolute value of this, the answer can be a positive answer or a negative one. So we need to write two equations. Take the absolute value bars down, and x plus 2 can be 0.5x plus 4, or x plus 2 can be negative 0.5x plus 4. So if we solve this, I'm going to solve the left one first. I have x equals 0.5x plus 2. Divide both sides by 0.5. 1 divided by 0.5 is 2x equals 2. X equals 1. Or, let's distribute that negative. Negative 0.5x minus 4. Okay, get the x's by itself. I get negative 6. And then add 0.5. I get 1.5. I just realized a mistake. Okay, let me finish this one, and then I'm going to fix what I did on the left-hand side. If you're watching this a different year other than 2018, it was time change this weekend, and my brain is not quite there. All right, now I need to divide by 1.5 and divide by 1.5. 1.5 goes into 6 4 times, so x equals negative 4. Now let's fix what in the world I was thinking here. Hilarious. I hope that you realize that, whoa, Miss Carly, you have lost it. All right, that's where we were. I divided. I don't know why. Let's go ahead and subtract. 1 minus 0.5 is 0.5. Now divide both sides by 0.5. 0.5 goes into 2 4 times. And there are two answers. Sorry about that. I hope you caught it while I was working. All right, moving on. Now, this may be brand new to you because we're going to graph this and try to solve our equation. We're going to actually let the left hand of the equal sign equal one function and the right hand of the equal sign equal another and figure out when they equal each other. So we're going to graph them. What I'm going to do is, oops, wrong button. Make one red and one blue. So I'm going to graph the linear equation first because that should be easier for us to do. My y-intercept is 1, and I'm going a slope of 1/2. So negative 1, negative 2, negative 1, negative 2, negative 1, negative 2. There we go. Let's try to connect those dots. Now for the red one. Negative 2, 1, 2, 3. So I'm just going to plug in x's and y's. If I plug in 0 for x, my y is going to be negative 1. And I can reflect that right there. If I plug in negative 1 for x, my y is negative 2. There we go. Connect some dots. And it looks like we have an intersection right there and right there. All right, so when does the function f of x equal the function g of x? What visual significance of the points where f of x equals g of x? So those two equal each other when x equals 4 and when x equals negative 4. We've got 4, 3, and negative 4, negative 1. So it's the intersections of those two. Is each intersection point xy an element of the graph f and an element of the graph g? In other words, do the functions f and g really have the same value when x equals 4 and when x equals negative 4? Well, let's go ahead and try it. I have f of x, so let's do f of 4. 4 plus 2 minus 3. 6 minus 3 is 3. F of negative 4. Negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. Minus 3 is negative 1. And then try g. G of 4. 0.5 times 4 plus 1 is 3. We're good. And then g of negative 4. 0.5 times negative 4 is negative 2 plus 1 is negative 1. We're good. Yep. All right, let's get into some examples. So we're going to look at explicitly how to use graphs of functions to solve an equation. So we need to label our graphs well. Remember, functions are functions, but when we graph them, it becomes a y equals. So a function is an equation where we can have inputs and outputs, and then when we graph them, it becomes y equals the function, right? All right, so solve this equation by graphing two functions on the same Cartesian plane. We're going to do a left side and a right side. So let f of x equals negative absolute value x minus 3 plus 4, and g of x equals absolute value 0.5x minus 5, where x can be any real number. We're looking for values of x at which the functions of f and g have the same output value. Therefore, we say y equals f of x and y equals g of x, so we can plot the graphs on the same coordinate plane. All right, so let's go ahead and graph them. Some of you have had a hard time, so we're going to go ahead and set up a t-table. So x and f of x, which this is really my y. I'm just going to put a few points in. If I put in negative 1 for x, negative 1 minus 3 is negative 4. Absolute value of that is 4. But I have a negative 4 plus 4 is 0. If I put in 0, I get negative 3. We have 1 there. And then if I put in 1, 1 minus 3 is negative 2. Negative 2 plus 4 is 2. I don't quite have my inflection point yet, but let's go ahead and graph what we have. So negative 1, 0, 0, 1, and 1, 2. This graph is tiny, so it's going to be hard. All right, we need a few more points. So let's go ahead and do, I think we need bigger points, 3 and 5. 3 minus 3 is 0, plus 4. 5 minus 3 is 2, negative 2 plus 4. Okay, that'll work. I'll show you why it'll work. 1, 2, 3, 1, 2, 3, 4. And 5, 2. So now I know where, oops. 1, 2, 3, oh goodness. I think that one's bad too. 1, 2, 3, 4, 1, 2, 3. Ah, that's why. 1, 2, 3. 1, 2, 3, 4. Sorry, this is really hard on this tiny graph. And then 5, 2. Now we see where we're going. That's decent. Let's go ahead and try the next one. X, f of x. So -1, 0, and 1 is just an easy place to start. Actually, I'm not going to start there. I'd like them to be, factors of 2, -2, 0, and 2, because when I multiply it by 0.5, it's easy. -2 times 0.5 is -1, or 1 minus 5 is -4. I get -5, and 2 is 1, -4. -2, -1, 2, 3, 4. That's terrible. -2, 1, 2, 3, 4. 0, -5, and 2, -4. So we see our pattern. So our solutions are going to be right around there somewhere. Your graph should be a lot better than mine. If I read this, it looks like our intersection points are at -4, 3, and 8, -1. That should be 8, -1. It's awesome. All right, the fact that the graphs of the functions meet at these 2 points means that when x is -4, both f of x and g of x are -3, and when x is 8, both of the other functions are -1. Therefore, the expression, these two expressions are equal when x equals -4 or when x equals 8. Therefore, the solution set to the equation is, when we do solution sets, we just list our x's. Try another one. All right, solve this equation graphically. So first of all, we're going to write 2 functions represented by each side of the equation. I'm going to do f of x, and I'm going to do that in color. I don't know what color I've been picking for the left and right, but it's all right. -x minus 3.5 plus 4, and then g of x equals -2, 5x minus 1. All right, we are actually going to try to do this in our graphing calculator. So I can set up y1 equals that function, and y2 equals the other function. All right, I graphed them in my calculator and opened a appropriate viewing window, which, if you see here, I've got 10 to -10 and 10 to -10 for my x min and y min, x max, y max. Determine the intersection point of the 2 functions. Well, this is really interesting. We can do a few different ways. I can show you in class tomorrow how to find the intersections of 2 lines, or intersection, using a function in your calculator, or I can trace my line and see where the intersection point is. This is more of an estimation. It can give you an accurate answer, but it can also be just an estimation. So to find the actual answer, it's an estimation, but I can always verify algebraically. So estimating, I went -2, -1.5, and 6.8, which is never easy to find on a calculator. Estimation, those decimals are messy, but using the intersection function, pretty easy. So let's verify. Let's set x equals to -2 and just test it algebraically. 0.25 times -2 minus 1. I get negative 5.5 plus 4 equals negative 0.5 minus 1. Negative 1.5 equals negative 1.5. We be good. And let's try 6.8. Did not leave enough room here. So absolute value of 6.8 minus 3.5 plus 4 equals 0.25 times 6.8 minus 1. I'm sorry. Negative 3.3 plus 4 equals 1.7 minus 1. So yes, 0.7 equals 0.7. Again, we are good. It worked. Alrighty. So use graphs to find approximate values of the solution set for each equation. Use technology to support your work. Explain how each of your solutions relates to the graph. Check your solutions using the equation. Okay, you're going to have to do a bit of this on your own to practice, right? So I'm going to graph the left side and the right side. So right there and right there. Absolute value is always going to give you a v. The left side is a linear equation with a y-intercept of 3 and a slope of negative 2 over 1. So down 2 over 1, down 2 over 1. Goodness, down 2 over 1. Your graphs need to be so much better than mine. You have no idea how hard it is to graph on a iPad. All right, this, I know my vertex is going to be positive 5, 0, and my slope is going to be 1. So my solution is going to be up here somewhere. I used technology, and I found that x equals negative 2. So I've got negative 2 comma 7 for my intersection. Plug that in. 3 minus 2 times negative 2 equals negative 2 minus 5. Let's see, that gives me 4. 3 minus 4 is negative 1. Oh no. Positive, that's 5. So sorry. I know how to add. That's a positive 5, and that would, oh, for goodness sakes. I wonder how many times I say that in a lesson video. You guys should start counting. Let's try that again. 3 minus 2 times negative 2. 3 plus 4 equals 7. Right? Okay. And then I have that equal to negative 2 minus 5, which is negative 7. And that equals 7. So we're equal. Phew, that was a little tricky, wasn't it? Actually, it wasn't tricky at all. We should have all gotten that one. Okay, left, exponential, dun 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 dun, and linear. Let's do the linear first. It's easier. So my y-intercept is 2, and my slope, 1.5, is the same as 3 halves. So I'm going to go up 3 over 2, up 3, 1, 2, 3 over 2, down 3 over 2, down 3 over 2. Try to connect those dots. Easier said than done. And here we have exponential. Okay, your graphing calculator can definitely help. I know this one crosses the y-axis at 2, and it curves up and down. So we should have 2 points. My awesome graphing calculator showed me that x equals 0. And then we've got the point 0, comma 2. And then the second answer is sort of hard to find. I've got about 2.7, 2.8, just using that trace function. So 2.8 if I round, 6.16, 6.2 to keep those in the same units. Cool. Alrighty. The graphs are shown. Use the graphs to approximate the solutions. Here and there is what I'm looking for, right? So I've got about, I don't know, x would be about negative 0.7, comma, negative 0.7 up to 0.6, 0.7, and over 2 up 4. But it's asking for the solutions, so just the x values. Cool. All right, next, let f of x equals x squared and g of x equals 2 to the x. Find all the solutions to the equation and verify the exact solutions. I'm going to graph those on my calculator. You can certainly also try a guess and check method. I don't know, just pick a number. We could say, let's try x equals 3. 3 squared equals 2 to the third power. That gives me 9 equals 8. Ooh, we guessed pretty close. X equals 4. 4 to the second power, 2 to the fourth power. 16 equals, hey, 16. Looks like we guessed and checked right. But yes, I can also graph it on my calculator and see that we're going to have a parabola and an exponential equation. Very cool. Let's see, I do need one more because exponential will give me 2 solutions. So my calculator right there is going to show me the other one is x equals about 0.8. So I've got my 2 solutions. Here's an interesting one. The graphs of f, a function that involves taking an absolute value, and g, a linear function, are shown to the right. Both functions are defined over all real values for x. Tammy concluded that the equation has no solution. Do you agree or disagree? I disagree because as y increases taller and taller and taller, this is going to keep on going, and at some point, well, they could also be, I know what we can do. Let's check our slope of this line and that line, because if those are parallel, then there wouldn't be a solution, but I don't believe they are. Let's just pick a point, and we're going to count up 1, 2, 3, 4, 5 over 1. So the slope of that line is 5 over 1. Let's see if I can find a point here. Maybe that one. So I'm going to go up, well, I can't even get up over 1. That'd be a big number over 1. So these two lines are not parallel, therefore there has to be a solution. Okay, that's my only test. The graphs of f, a function that involves taking the absolute value, and g, an exponential function, are shown below. Sharon said the solution set to the equation is exactly negative 7.5. Do you agree or disagree? Let's see. So at negative 7 is one solution, and at 5 is another solution. Oh, that looks right to me. Looking at the graph, it looks correct. I guess the problem I have is exactly. We can't test it. We can't verify. I can't plug it into the equation and check. Tricky, huh?